Okay, hi guys. Good evening. Welcome to week 4 of zku, Zero Knowledge University. Okay, so in this demo, we're going to be talking about zkSync. So basically, zkSync is a privacy engine. It's run on Ethereum, and it rolls up transactions from zkSync to Ethereum using a zk rollup technology, which is an L2 scaling solution. Basically, what this does is that there's a smart contract on Ethereum that holds all the funds, and then once that smart contract interact with the zkSync server, and then the zkSync server creates a replica of those funds that are being held on Ethereum, so that those funds can be transacted normally in zkSync at very low cost, because it doesn't have the bottlenecks of Ethereum. And then whenever when transactions are done, the batch is being proved to be done correctly and then rolled up to Ethereum. So it's getting the security from Ethereum, but also the cheap computation resources from the zkSync server. Let's just go into the source code. So to set up zkSync on your local host, you need to follow some of the documentations already outlined in the zkSync repo. We have the, let me just put this, yeah. We have the setup dev environment that gives you all the necessary dependencies that you need to set up on your system. And then you have the launch document that shows you how to install zk. Once you follow those two, you should be good to go. And once you do that, by pressing zk, you should also have this message on your screen. So, 1 minute. Okay, so after that, let's quickly do a short demo of how zk works. So this is a wallet on zkSync. This wallet should be on the test network. Yes. So we are going to move some money from our Ethereum wallet and add it to zkSync. So in order to do that, we're going to add funds on account. So let's add to it. So now, what is going on now is that we are sending money from our Ethereum wallet to zkSync smart contract. Once that money is being sent, at this point, the smart contract is going to hold on to that money and then communicate with the zkSync server that I've sent certain amount of money, and I should be credited that same amount on the zkSync network. So this will take a little bit of time, so we're just going to jump out, but we can see the transaction already on Etherscan. So also there's a zkScan similar to Etherscan that shows you transactions that are done on the zkSync network. So while that is going on, let's just move on. Let's discuss the architecture of zkSync. So zkSync basically comprises of a smart contract, a solidity smart contract that is written in Ethereum on Ethereum's blockchain. And this smart contract manages the user's balances and verifies the correctness of the operations performed in zkSync. So what does that mean? It basically means that the zkSync application, that is the server application, if you come to the source code, basically, let me just explain before I go to that. Basically, the zkSync server application does a bunch of transactions, right, off-chain. So once it's done with all those transactions, it batches all of them up and then sends a proof that all those transactions were done correctly to the smart contract. Now, the smart contract verifies that that proof is correct with zero knowledge. Once the smart contract can verify that the proof is correct, it accepts that transaction, and then it records the change of state. So if, take for example, I enter the zkSync network with 2 ETH, within the zkSync network, I transferred 1/8 to person B. Now, when the transaction is sent back to the smart contract, the smart contract verifies that that transaction was done properly and then debits my position on the smart contract with 1/8, so that when I'm eventually withdrawing out of the zkSync network back to Ethereum, I only have 1/8 left. So it's not correct. So that's what the smart contract does. Now there's the proof application. This proof application, all it does is to create the proof that the smart contract will verify. There's also the server application. Basically, the server application is the entire zkSync network outside the Ethereum blockchain. So that is where transactions are being done, where the chain blocks is being generated. So you can think of the server application like as its own blockchain. You can call it a side chain, where proofs are being requested, and then it's also the server application that publishes data to the smart contract. So basically, it publishes data as call data, and that is really, really cheap. So now there are two ways you can build zkSync. You can either build as a monolith or as a microservice. In this demo, we're going to be looking at the microservice architecture. Basically, that is it. Let's just check the transaction. Okay, so the transaction has been verified, and okay, this will still take a bit of time. So now the transaction has been verified and it's entering my zkSync network. So once it enters the zkSync network, I should be able to see it in my transaction. But this is one that I've done before. And once I can see it in my transaction, I should be able to also be able to see it on zkScan. So this is just a copy of zkScan. You can always check it out. So let's quickly check out the source code. So the zkSync is built in Rust. That is the server application, but it also builds certain SDKs, like there's a JavaScript SDK and a Rust SDK. So the zkSync application, I'm just going to run through two basic functionalities. Let's start with the it signer. Yeah. Okay. So this module, basically the Ethereum sender, is what is responsible for synchronizing the operations that happen on the zkSync network with the operations that happen on the Ethereum contract. So you can think of it as this: whenever a transaction is done on the zkSync network, it has to be relayed to the Ethereum smart contract with a proof that it was done correctly. And this module is what is responsible for that. So basically, on a high level, what this module does is that it batches a bunch of transactions in a first in, first out order, and then sends that transaction to the Ethereum smart contract for verification and application of related all the transactions. Okay, so we'll be looking at the zkSync smart contract. So this is the smart contract on the Ethereum mainnet. So it's an upgradable contract. So let's look at some key functions such as the deposits ERC20 tokens to layer 2. So basically what this deposit ERC20 token does is to what it does is to allow the user to deposit tokens into the smart contract, validate it, and registers the deposit. So if you look at the function, it ensures that the address is not a special account address, there's some special account address. Then it also validates the token address, which is the address of the token. Then after everything is done, it registers the deposit. So if we go and check out the registered deposit, so the way zkSync works is that if you see it, it has a priority queue. So once you try and deposit into the zkSync network, it adds that deposit to the priority queue to be treated by the network admins. So that's what it's doing here, and then it emits an event, which is the deposit event. Once that is done, the deposit is registered. So let's look at withdrawal. So to withdraw from the zkSync network is similar to the deposit. Basically, you are transferring the ERC20 tokens back to your address on Ethereum contract. So if you check out the register withdrawal, it's a similar process. It adds it to the priority request to be treated. Now, this priority request, if this priority request is not treated, when you try and withdraw, you can initiate something called the Exodus mode. So let's look at that. If you are being targeted, or if you are being censored on the zkSync network, this Exodus mode allows you to initiate. This Exodus mode allows you to withdraw your funds without the zkSync network validators. So let's look at the source code for that. So now if we look at the it's triggering this in the Exodus mode. And basically what this Exodus mode does is that first of all it checks whether there's already an Exodus mode existing, and if there is no Exodus mode, it initiates an Exodus mode. So once an Exodus mode is initiated, anybody can perform an Exodus. So basically what that means is that roll-up activities are stopped, and then users can withdraw their funds. So finally, let's look at the block proposal. So the block proposal, basically in basic terms, it pulls transactions from the mempool and then sends it to the state keeper. It does this by in small batches, known as mini blocks, and they are much smaller than the full blocks. And remember when I said that you can think of the zkSync network as a sidechain, like a blockchain. So it basically does the same thing. It puts its transactions in blocks and then tie them the same way we do it in Ethereum. But the only difference is that it's not doing it on a network of various actors, basically. So it still needs a security layer, which is Ethereum, to make sure that transactions are done correctly. So basically, block proposal has 4 data types. We have the root hash queue, we have the current priority operation number, the mempool request, and the state keeper request. Just to circle back, the Ethereum transaction that we deposited, we can see it in both itscan and zkScan. So on itscan, we are sending it to a contract, which is the zkSync contract. And on the zkScan, we can see that it has been sent to our address, which is also the same address. So it basically has been sent to our address on the zkSync network. So if we check our address on the zkSync network, we should be able to see our balance, which is 3.0. So I will just take a moment to talk about zkSync 2.0. Yeah. So basically, the zkSync 2.0 is riding on this thing, on what was built in zkSync 1.0, but it also creating a permissionless EVM compatible smart contract network. So basically what that means is that you can, your smart contract have already been deployed on Ethereum, you can move it over to zkSync and deploy it on zkSync. And then people that bought that bridge their money from Ethereum to zkSync can use zkSync and interact with your smart contract. So you can build things like games or whatever on zkSync. Now, one of the key things about zkSync 2.0 is zk Portal. Now, zk Portal promises is offering you off-chain data availability. So remember in zkSync, we are publishing our data as core data to Ethereum. In zk Portal, it's not being published. So it's everything is available off-chain, but it's publishing the zero knowledge proofs. So a change of state cannot happen on the smart contract without a zero knowledge proof, right? So that is basically it for zk Portal. Thanks for joining. See you guys on the channels.